Hello everyone, so today I'll be discussing question number 32 of GATE 2014 set 1. For the truss shown below, the member PQ is short by 3 mm. The magnitude of vertical displacement of joint R in mm is. So here is a truss which is given to us. Here they are saying that this member PQ is short by 3 mm. So because of which, what will be the magnitude of vertical displacement of this joint R? So it's a fill in the blank type of question of 2 marks. For this type of problems, you can refer to lecture series on Structural Analysis 1 by Professor Amit Shaw, Department of Civil Engineering, IIT Kharagpur. Let's start with the solution of this problem. So here we need to find the vertical displacement of this joint R because this member PQ is short by 3 mm. So for that we will use the unit load method. So the first step of applying this unit load method is to apply a unit load in that particular joint where we have to find the displacement. So we will apply the unit load at joint R in vertical direction. Okay, so the second step is to find the internal forces in all the members due to this applied unit load. So we will find the forces in all these members due to this applied unit load. And the final step is to apply the formula which is based on the virtual work principle. That is, displacement of this joint R will be equal to summation of U multiplied by lambda. Here U is the internal force in different members due to this applied unit load, and lambda can be due to externally applied load or due to temperature change, or in our case it is because this member is short by 3 mm. So let's start with the first step, that is finding the internal forces due to this applied load. First of all, let us find out this value of theta. So sine theta here will be, or we can find out tan theta here. So tan theta will be equal to perpendicular divided by base. So theta here will be equal to 36.869 degrees. Now if we analyze this joint P here, so here it is joint P. This force, let's say it is UPR. This force here will be UPQ. Also, since we have applied this unit load 1 here, so the reactions will be downward in both P and Q, and magnitude will be 1 by 2 because it is a symmetric case. So the loading will be equally distributed among supports P and Q. So here we also have this loading in downward direction, that is 1 by 2. Now let's find out the value of UPQ and UPR. So if we satisfy, this is angle theta, so if we satisfy the vertical equilibrium, so here it will be UPR sine theta will be equal to 1 by 2. From here UPR will be equal to 0.5 divided by sine theta. So from here we get the value of UPR as 0.833. So we got the value of UPR. Now we will find the value of UPQ. So UPQ we can find out by satisfying the horizontal equilibrium. We satisfy the horizontal equilibrium here, that is force in horizontal direction to be 0. Therefore from that we get UPQ plus UPR cos theta equal to 0. That is UPQ plus UPR cos theta equal to 0. So UPQ will be equal to minus UPR cos theta and we also already know the value of UPR here, so UPQ will be equal to minus 0.667. So we know the value of UPQ and we know the value of UPR. URQ will be equal to UPR only. Now we can put the values in this final formula, that is delta R equal to summation of U multiplied by lambda. So if we will expand this formula, we get delta R equal to UPR lambda PR plus URQ lambda RQ plus UPQ lambda PQ. But the value of lambda is only given for this PQ, that is only PQ member is short by 3 mm. All the other lambdas are 0. So this term will become 0. This term will also become 0. So finally the lambda R will be equal to UPQ multiplied by lambda PQ. We know the value of UPQ, that is 0.667, and the lambda value is 3 mm, minus 3. Why? Because it is short by 3 mm. From here we get the value of delta R, that is displacement of joint R, as 2 mm. So the magnitude of this displacement is 2 mm and the displacement is happening in upward direction. Why? Because we assumed the direction to be upward here and we got our answer positive, therefore our assumed direction is correct. Therefore this joint R will displace by 2 mm in upward direction. And in our question they asked only the magnitude of the vertical displacement in mm, so the answer will be